We are going to be reviewing sections 6.1 through 6.4, which was solving systems of equations. There were three methods that we learned to solve. The first method in 6.1 was to solve by graphing. If you look at your handout, you will notice at the front page and on the next page there's two additional problems. All 6 of those problems we are solving by graphing. That means we need to graph each of these equations and then figure out where the lines intersect. I'm going to start with problem number 4. So if you will look at that one with me, please. Please fill out your paper as I go through these examples. In problem number 4, the very first thing we need to do is put our equations into slope-intercept form. Remember, slope-intercept form is y equals mx plus b. In our first equation, to put that into slope-intercept form, we are going to need to subtract 2x from both sides. So that's what I'm doing right now. When we subtract 2x from both sides, we should be left with y equals negative 2x minus 4. Remember, we write our x term in front of our constant, so I did write negative 2x in front of minus 4. Now this equation is in the form of y equals mx plus b. I'm going to go ahead and graph this one while we're working with this particular equation. The y-intercept is where we begin, which is our b value. Our b value is negative 4. So put a dot at negative 4 on your y-axis. From here, we will use our slope to rise and run. Remember, slope is always a fraction, rise over run. In our particular case, it's negative 2 over positive 1. So from my point that I've plotted, I'm going to go down 2 units because it's a negative 2. The 1 is positive, so I'm going to go over to the right a positive 1 and put a dot. I'm going to continue this pattern of going down 2 and right 1. Now notice we can't go any further because we will be off the graph. So another alternative is to go up 2 points or 2 units and left 1. We can continue on by going up 2 and left 1, up 2 and left 1. I'm just going to go ahead and extend this out. I would like for you to have a straight edge to draw your graph. So if you don't have one, you're welcome to borrow a ruler, which is located in the front of the room on the table next to the door. So if you don't already have a ruler, grab one, please. And if you have a ruler or some kind of straight edge, go ahead and draw the line through your points. This line represents the first equation. We now need to graph the second equation. So like the first one, we're going to put it into slope-intercept form. So to do that, I'm going to subtract 2x in the second equation. So our new equation is y equals negative 2x plus 3. Again, in this instance, I wrote my x term first, my constant last. So when we graph this one, which is in slope-intercept form, begin by plotting your y-intercept, which happens to be 3. You should also notice that our slopes are exactly the same. It is negative 2. So we talked about this. When our slopes are the same, that indicates that your lines are parallel. So we should have 2 parallel lines here. So let's go down 2 and right 1, just like we did on the previous graph. We could have gone up 2 and left 1. Once you've got several points plotted, go ahead and draw the line through with your straight edge. Now, ultimately, we're looking to figure out where our graphs intersect. Obviously, if the graphs are parallel, they will never intersect. So in this particular case, we would say that we do not have a solution. There is no solution. And we would use the symbol of no solution, as I've got drawn on the bottom of the page here, to represent my solution or my answer for this particular problem. Now, for these other problems, you will need to come up with an ordered pair. If they have a solution, we would have an ordered pair as an answer. Now, there may be instances where you graph a line and then your second equation is the exact same line. Remember, when that happens, we say that there are infinite solutions. So this was an example by graphing, solving systems by graphing. Again, I'm looking for you to graph each line and then give the solution if there is one, an ordered pair, no solution, or infinite solutions. Please turn to example number, let's do example number 9, please. In this next group of problems, we are working out of section 6.2, which is solving using the substitution method. Remember, to use substitution, we need to begin by solving one of the equations for a variable. We need to get one variable alone. It doesn't matter if it's x or y. You pick. Now, looking at problem number 9, I'm thinking that it's going to be pretty easy to get x alone. So that's what I'm shooting for. So to get x alone, I'm going to subtract 2y from both sides. So I should be left with x equals 6 minus 2y. And it really doesn't matter if your y term comes in front of your constant 6. So we're going to take 6 minus 2y and we're going to substitute it in to the other equation for x. So again, I hope you're filling this out with me as we go along, because these are answers to a few of your problems. So let's substitute 6 minus 2y in for x. We have 3 times. Notice I am using parentheses. I'm using parentheses because I'm substituting in more than one term, and I want to be sure that I distribute that 3 to both the 6 and negative 2y. So go ahead and distribute. 3 times 6 is 18, and 3 times negative 2y is negative 6y. Combine your like terms. Here we have negative 6y and negative 4y, which is a negative 10y. Continue to solve. We can subtract 18 from both sides. Negative 10y equals 10. From here we can divide both sides of the equation by negative 10. Y equals negative 1. Now we have half of our answer. We have the y coordinate. We do need to find the x coordinate. Remember, to do that, we're going to take the value of y, which happens to be negative 1, and we're going to substitute it back into one of the equations up above. It really doesn't matter which equation. I'm picking this one because it's going to be the easiest algebra to do. When we substitute in, we have 6 minus 2 times negative 1. So really, negative 2 times negative 1 is a positive 2, and 6 plus 2 is 8. Our x coordinate is 8. Our y coordinate is negative 1. Remember, your solution is where these two lines intersect graphically. Now, algebraically, your solution is the ordered pair where they would intersect. We would write our answer as 8, negative 1. That is an example of substitution. The next example we're going to look at is on the last page. Let's look at example number 15, please. In this section of your assignment, we're looking at sections 6.3 and 6.4, which are solving equations using the elimination method. In elimination, we are looking to get opposite terms. Sometimes the problems will already have opposite terms. For example, look at number 12. Number 12, you'll notice that we have opposite terms in our equation, 6y and negative 6y. So I don't need to do anything to my equations. Now, in 14, we have negative 6t and negative 6t. Those are not opposite terms, so I will need to do something to one of those equations, or at least one. Back to problem 15, notice we do not have opposite terms. I'm thinking I could probably easily get opposite terms by multiplying the top equation by 3. I'm thinking ahead here. I'm thinking if I multiply the top equation by 3, I'll have 3x plus 3y plus 6. So that 3x here is going to be an opposite term with that negative 3x, which is exactly what I need in order to perform elimination. So let's go ahead and distribute the 3 throughout the top equation. We have 3x plus 3y equals 6. Now in elimination, we always like to add the equations together. So I'm going to ignore that top equation because I've now multiplied it by 3. When you add your top equations, obviously the x's will cancel each other out. 4y plus 3y is 7y. And 15 plus 6 is 21. Continue to solve by dividing by 7. Y equals 3. Just like we did in substitution, we need to find the x coordinate. To do that, we're going to take 3 and substitute it back in to one of the equations. I'm going to choose the top equation to substitute back into. So I have x plus 3 equals 2. To solve, I can subtract 3 from both sides. X equals -1. Our solution is -1, 3. Again, this is elimination where we are eliminating one of the variables to solve the equation. Guys, it is very important that you remember these 3 methods because tomorrow we will take this a step further and we'll apply systems of equations. We will look at some word problems that we will have to solve, and it's important that you can do substitution, elimination, and graphing because all 3 are efficient methods for solving your systems, and I want you to be able to perform any and all operations at any time. So your assignment for today is to complete this packet. There are 17 problems, but you should have already 3 of them completed, which should leave you with 14 problems left. I plan to be back at school and available for help if you need it during advisory. Come in and see me. There will be no tutoring this week, so I am available for you to get help if you need it.